Okay. Today I actually today's gonna serve a dual purpose. The first, I'm going to test the live streaming capability of my setup, as weird as it is. And also I want to talk a little bit about the brain. The brain. The brain, which is my actual area of proper study and work. So the test of squeaky chair. The test of the live stream will just I'll check it myself afterwards, so it doesn't even matter. But let's talk about the brain. Um, the brain is really interesting. It's made up of tons and tons and tons of little cells. The majority of which we call the ones that we think are functioning as the brain, we call neurons. They're surrounded by astrocytes, oligodendrocytes, microglia, all of these very, very interesting and very important cells. And until recently, we didn't think they were doing anything that's actually signaling related, but we've certainly been proven wrong these days. But we'll get into that in the future. So the brain really works perhaps counter to how many people perceive it to, in that we think the brain is a very electrically based organ, and it genuinely is. It's one of the most electricity or voltage based organs in our body, but the way that signals are actually generated in the brain are not. Or I should say, the way that signals are transferred from one neuron, which remember is the key cell of the brain. A signal that's transferred from one neuron to the other is not always electrically. In fact, for the majority of the time, it is not electrically. And so the vast majority of signal is actually transferred via chemicals. And that's why, substances that alter our brains work so well, because they get right into where they're supposed to and really bias our brains to do something different. So, of course, everyone's heard of dopamine and the way that it, what the role it has in pleasure, etc., etc. And that's the point, right? By essentially acting on these chemical receptors for dopamine, we can prolong, enhance, do all sorts of crazy and interesting things in the brain. And so we think that the brain uses a chemical transmission because it is more, not only is it more robust, it is also capable of more complexity. And by that I mean a electrical signal is insanely fast. The time that an electrical signal in the brain appears and dissipates, or how far it travels along the brain is too fast for our day-to-day actions. And so the brain has evolved to need to, and when we see this when we just exist by mere existence, the brain needs to summarize not only data that happens at this very, very, very instant, but also stuff that's happened, a second in the past and looking forward to a second in the future, etc., etc. And so the brain does this via chemical signaling and via neuron to neuron interaction. And that's what makes the brain so complex, because in a hand wavy engineering kind of way, we can say that almost every neuron is connected to every other neuron in the brain, which means that the network that exists is of such breadth and depth and complexity that it's not something that we can truly comprehend unless we spend years and years and years and years trying to tease out every little bit, which of course a lot of us are doing right now. And so that also does then mean that if we lose some of these neurons, that even losing a little bit can have a dramatic impact depending on where we lose it, of course. And we can see that very clearly in unfortunate victims of brain trauma, of genetic diseases, etc., etc. And a interesting side example, one that I use a lot, is actually something completely unrelated to the human. It's why I consider, at least I sometimes consider small, like really, really small, like 1 pound dogs, why I consider those to be animal cruelty, simply because we know that dogs evolved from wolves, and wolves have nice and big brains, and through selective breeding, active selective breeding of the human, we have shrunk the size of a wolf brain down to 1/10, 1/50th of its original size. And if we go back to what I was talking about earlier about the brain being connected, the neurons in the brain being connected to each other, and that's where the complexity comes from. Well, that means that we are being absolutely cruel to these puppies, to these 1 pound dogs, because their brains aren't really designed to work with so little neurons, and that's why they're always afraid. That's why they have so many abandonment issues. That's why we tend to classify them as less smart for those exact reasons. So yeah, small dogs, animal cruelty, animal cruelty. Anyway, um, uh, well, right. I was wanting to talk about those chemical connections again. And at any point in time, those connections in our brain are almost always active, but at a very, very low rate. And this is actually very important because that low rate of constant activity is what maintains the brain from shrinking. Um, I'm sure everyone has heard about the fact that that our brain uses the most energy in our body basically ever, and for good reason, because it needs to do all these really, really complex things for all these really, really complex reasons and respond to essentially every piece of stimulus that our body gets. And so, because it requires so much energy, any part of the brain that is not needed will, simply by nature, slowly wither. And that is not done because our body wants us to be stupid. That is done because our body wants to conserve energy. So by reducing the parts of the brain that are not necessary, we actually can save a lot of energy. So going back to the activity that's present, well, the activity that's present on a molecular level that keeps our brain from shrinking is actually really interesting in and of itself, because these are no longer these are no longer statistical events. We can't summarize them over a period of 5 to 10 minutes and then just assume that's what happened in those 5 to 10 minutes. Each event, each chemical release of a brain cell is its own. Like, we have to treat them individually, and this is important for a lot of reasons. But the underlying reality is this is just how quantum physics works, because at the level of where our neurotransmitters are stored and how they fuse with the brain cell, and how that then diffuses across that very tiny space between two cells, that is all governed actually at that point by quantum mechanics, because at that point it is um, almost single atoms interacting with single atoms, and that's why we have these very discrete stochastic events, releases, and why we've come to see the brain itself as being not a something that we can summarize at all. It's just, it's too compartmentalized, it's too discrete for us to really treat overarching systems, um, and it's like looking into a black box. Essentially, we have to build the brain from the bottom up, and we can't go into it from the top down. And so yeah, it's just due to the randomness of quantum mechanics, that's why sometimes our brains make these random connections. And if I may sort of step into the metaphysical for a moment, to me, this is partially this type of randomness, the randomness that exists within quantum mechanics, is what is essentially the fundamental building block for what I would call the human condition. So how humanity acts and why we sometimes do things that seem weird, not just to others but also to ourselves. It's this ability for us to generate new ideas, new information that makes us dramatically unique, but it's also that same randomness that sometimes causes us to suffer. And one of the one of the biggest and most I guess most powerful examples I have for myself, at least, is this idea of nostalgia, where sometimes just randomly by hearing a song, smelling a certain smell, seeing a sight, that we're suddenly overcome with this powerful sense of um, not this powerful sense, but a powerful memory of our past. And to me, on some level, that is just randomness of the brain working, but it's also a very powerful reminder of just how much information our brain is storing and how much it is being used every single day. So randomness, it's amazing, and it's actually really helpful for when we're trying to be creative, but it's also one of our biggest downfalls in our current society, because we have so much free time and because we have so much, our bodies are so well fed, even sort of, okay, let's say in the developed world, in the first world nations, um, the vast majority of us, even in the lower classes of society, are fed well enough that we have time and energy to burn to do nothing. And that's partially what I would say is troubling, because the same randomness that helps our brains, pull up and refresh old memories, or to keep us alert when it's dark, are also the same factors that keep us thinking too much always. And so it's this very, shall we say, very disappointing part of us, because not it's super useful, but it's also what holds us back, right? So by that, I tend to mean this idea of, there are a lot of us who will, in the quiet of the night, or even when it's not particularly quiet, even when we're just alone, get stuck in our own thoughts. And it seems like we try to stop it, but it won't stop. And to me, that's the trigger oftentimes is the randomness within the brain, and it is then perpetuated when we don't have enough organization. And in my past broadcast, if I may pull it up, about personal growth, I talked about mental organization for a little bit, about how we're unable to focus, and how, for me at least, one of the ways that I manage with my mental organization is to just scream certain parts of my thoughts out into the ether, like I'm doing right now, and hope that that's enough for it to just disappear for a while. And that does work for me, but it doesn't work for everybody. Well, I think on second thought, it might work for everybody, but it's just that most people are not are not able to push themselves to do it. Regardless, um, uh, the point here being that the randomness in our brain is very, very powerful, but it's also one of our downfalls, and we need to control it. Right? It's part of our human condition. It is not something that we can get rid of, because once we get rid of it, we also get rid of the beauty of just how wonderful the human brain can express itself and behave. All of these things that make us unique are also what, if we leave them unchecked, are also what make us, what harm us. And so it's just very important for us to not allow it to do so. I got completely off track. I was talking about the brain. Let's go back and talk about the brain, or rather, just to summarize, it's 16 minutes. Yeah, just to summarize. In summary, then, the brain is very powerful. It is made up of billions, trillions of cells that are doing lots and lots of very, very powerful things. It's keeping us alive, and it's all done, well, not all, it's majorly done, majority done through chemicals. And these chemicals in our brains are good if we're healthy, but when we're not healthy, these chemical imbalances can cause all sorts of weird and upsetting things. And that's why, antidepressants work really well for some people, but also terribly for others, because the chemical imbalance is just not something that we have the ability yet to properly understand. I do hope that in the future we will have the ability to do so, and when that happens, I'll be very, very happy. But for now, that is not the case, right? And so for now, when the thing that makes us human also makes us sad, we have to deal with it by organizing our minds. And I talked a little bit last time about just crossing out random things, not random things, crossing out things on a to-do list, and when, as you cross it out, you realize that that's actually quite important, and so you do it. And that's honestly been my philosophy so far. It's to make my life for me as easy as possible so that I can do the things that I want. And to be distracted again, to go on this anecdote, that's exactly why I'm testing this live stream setup, because live streaming is so much easier than me having to record my voice, push it into a video editor, and then edit as I go along, and then post it to YouTube. If I can just press, how many buttons was it? One, two. If I can press two buttons and just start talking based on, 3 pieces of notes that I have, then that makes it much easier, but also more importantly, much more likely that I will continue this type of thing. And not saying that this is not without benefit to others, but the most benefit that this is for myself to organize and to practice speaking consistently, and just having fun while doing so. I think that is it for today. I can't believe I've gone 3 minutes of wrapping up on a 16-minute, 15-minute talk. Oops. But I do go on tangents a lot. And, well,